After this lecture, you should be able to explain the difference between pure substances and mixtures, between elements and compounds, and between heterogeneous and homogeneous mixtures. Let's start off with what a mixture and a pure substance might be. All right, up on the slide right now, we have examples of a lot of different kinds of matter. We have chocolate, we have water, we have silver, we have brass, a brass bucket. All right, just by visually looking at things at the macroscopic level, macroscopic meaning big level, the level that we live at, you can't really tell what's pure and what's a mixture that well. There will be some techniques that we will be able to use to try to take a really reasonable guess later. But in order to really find out what's pure and what's a mixture, you really have to zoom into the submicroscopic level, the level that's smaller than a microscope can see, the level of atoms and molecules. If we look at chocolate first, we can see that chocolate's made of some molecules, right? And these are drawings of molecules up here. We have some fat molecules, and we have some theobromine molecules. Theobromine, by the way, is the molecule that makes people get a little addicted to chocolate, makes chocolate make them feel good. And actually, there are other molecules in chocolate. I just haven't chosen to represent them. Right. Since there's more than one kind of piece in chocolate, more than one kind of molecule, chocolate is a mixture. It has several different kinds of compounds in them, and those compounds are not attached to each other. On the other hand, if you look at water, water's made of molecules as well. It's made of molecules with a hydrogen and an oxygen atom. Here's the hydrogen right here, and here's the oxygen right there. And here's another hydrogen. And they're attached. You can see the bond. All right. So the attachment means that those atoms are in together in one piece. So this is one water piece, one water molecule. This is one water molecule here. Here's another that's not actually attached between those hydrogens. They're just next to each other. All right. Water is not a mixture, though. Water does have hydrogen and oxygen in them, but since the hydrogen and oxygen are attached into one piece, we look at the molecule that results. We look at the piece that results. And all of the pieces in this picture are all identical to each other. They're rotated a little bit, and sometimes you can't see all the parts, but they are all identical. That makes water actually pure substance, not a mixture. All right, down at the lower left, we see silver. Since there's only one kind of atom there, this is pure as well. So water is pure, silver is pure. And finally, we get to the last example. No attachments in brass. We have a zinc atom here. We have a copper atom there. Since they're not attached to each other, and they're just kind of sitting there next to each other, and there's more than one kind of atom, that is a mixture as well. So let's summarize by going back to the last slide. So chocolate doesn't really look like a mixture if you look at the chocolate bar. Yeah, there's the chocolate bar. It doesn't really look like a mixture, but it is a mixture because it's made of more than one kind of molecule. Water doesn't look like a mixture either, and it's not. It's a pure substance. Even though it has different elements in it, those elements are in water molecules, which are now defined as the piece that makes up water. Silver bars contain silver atoms, so that's pure as well. So pure, mixture, and mixture. A substance is a single kind of matter with uniform and definite composition. Uniform meaning the same anywhere you look in the world. Definite meaning it's always going to have a certain quantity or number to it. Right? Mixture. A mixture is a physical blend of two or more substances. We're going to talk later what physical means, but it pretty much means it's not bonded. It's not chemistry exactly that puts them together. They're just next to each other. And that's why mixtures can vary their compositions. For instance, you can go and add a little tomatoes to your salad, a lot of tomatoes to your salad, but there's no definite composition to a salad. There's no authoritative salad recipe out there. There's lots of different recipes. So that's why salad's a mixture. All right. A heterogeneous mixture is a kind of mixture. It's not a kind of pure substance. But a heterogeneous mixture is not uniform in composition. You can see the pieces in it. So an example of this would be soup, where you can see the chunks in it, or salad, or some other kind of concrete, for instance, where you can see the little rocks and the sand pieces. Right. A homogeneous mixture is uniform throughout. It's still a mixture, but you can't really see the pieces. Milk is a homogeneous mixture. All right, compounds are made of elements. An element is the simplest form of matter that can't be separated into simple pieces. All the elements that we're going to be working with in class are on the periodic table. So you can look to the periodic table if you're unsure if something's an element. If it's on there, it's an element. If it's not, it's not. Compounds are made of two or more elements. Any substance pretty much that isn't on the periodic table is either a mixture or a compound. So compounds have chemical bonds in them. So you require chemistry to separate them. You have to break the bond. They have a definite and fixed composition. So compounds are actually substances. Compounds are pure substances. So water is a compound. It contains hydrogen and oxygen with bond. And water is a pure substance. All right. Compounds can be made of molecules, ions, other kinds of items. Finally, atoms and molecules. These are the small pieces when we look at it in the zoomed-in view. Atoms make up elements. Molecules make up compounds. Atoms are those small little dots, the small little pieces of elements. Molecules are made up of atoms, but that are bonded together, that are attached. So molecules are the smallest particle of a compound that has all the properties of that element in it. And pure substances can be made of atoms, or they can be made of compounds. All right. So we might have a little bit of a trouble still now telling the difference between a molecule and an atom, or an element and a compound, just by looking at it. So here's some tips. Let's go back to the idea of the picture at the beginning. In the picture at the beginning, we saw chocolate, water, brass, and silver. So how can you tell which one's a compound and which one's a mixture? Both compounds and mixtures are made of different kinds of elements. Sometimes the elements are bonded, like in compounds. Sometimes they're not bonded, like in mixtures. All right. Mixtures still have the properties of the substances in them. For instance, if you put sugar in water, mix it up, it's a mixture. How do you know it's a mixture? It still tastes sugary. If it was a compound, it wouldn't taste sugary anymore. Compounds have new properties that are not as same as the elements. A really good chemistry example is that of salt. Salt is sodium chloride. Salt is made of sodium atoms and chlorine atoms, but they're now bonded. They're chemically different. And we can definitely see this if we look at what sodium and chlorine look like if they're separate. Sodium is actually a really soft metal that actually lights on fire in water. If you want some fun times, go Google or on YouTube, look up sodium water. You'll see some interesting stuff. So anyway, salt is not a metal, and it's not flammable in water. Chlorine normally is a toxic green gas. Salt is not toxic, nor is it green, nor is it a gas. Salt is this nice little granular stuff that we put on our food, and we don't really have to worry about it lighting on fire on our tongues. So anyway, the way that we know salt is a compound, not a mixture, is that it doesn't act like the things that are in it. That's evidence that new bonds have formed. All right, we can also tell the difference between compounds and mixtures because compounds have one fixed indefinite composition, so they always have chemical formulas to them. So water is H2O, and it's always H2O, 2 hydrogen and 1 oxygen. All right, mixtures can have varied compositions. You can add different amounts of sugar to your coffee. You can add different amounts of milk to your coffee because it's a mixture. All right, you have to copy this down, angry slippers. But luckily, we probably did this in class already. If we didn't, you have to copy it down. But this kind of shows the relationship among the different terms that I just went over. All right, let's do some examples of classifying substances. So we're going to tell, is it a compound or an element? Is it a pure substance or is it a mixture? If it's a mixture, is it homogeneous or heterogeneous? So first, let's ask air. Well, again, we can't really see pieces in air, so I don't know. Is air an element? Well, air is not on the periodic table, so it's not an element. Is air a compound or is it a mixture? Well, air contains oxygen, and that oxygen is probably not bonded with things because we can actually breathe it as oxygen. Also, you guys probably know that air, you can have bad things in air, so it can be mixed in, like carbon dioxide or carbon monoxide. You also probably know that sometimes there's not enough oxygen in air, so air doesn't have a fixed composition. That's why air is a mixture, and air is a homogeneous mixture because you can't see the pieces in it. Water, salad, milk, we all kind of gone over already. Gold. Is gold on the periodic table? It ends up it is. So since gold is on the periodic table, it's a pure substance and it's an element. However, that's only 24 karat gold. If you have 18 karat gold, 16 karat gold, 12 karat gold, 10 karat gold, any other kind of gold, that gold is actually a mixture. Only 24 karat gold is pure gold. Oxygen is a pure substance. Oxygen is O2, though. Is that an element or a compound? It actually doesn't fit the definition of a compound because there's only one kind of element in it. There's only O in it. There's only oxygen atoms in it, even though there's 2 of them. So oxygen is this weird thing that it's a molecule, but it's actually an element. So this is probably one of the only situations when something can be a molecule and not a compound. It's a molecule and an element instead. It's there. All right. You can separate mixtures based on their physical properties, their particle size, melting boiling point, solubility, density, color, and magnetism. And here are 2 really common techniques that we use: distillation and chromatography. Distillation is pretty much you boil or you heat something up. If it has a lower melting point, it will come off first, and you'll be able to collect it. And if it has a second lower melting point, it will come off boiling point, it will come off second. Chromatography lets you separate a solution. All right, this is an example of chromatography. I actually did this one in school. On the left, you can see that's a column of sand. The compound started at the top, and they were pushed through the sand, and you can see all the bunch of different colors there. Those are the different compounds that were now separated. On the right, we can see a piece of paper that you might have done this in forensics class. You let the solvent go up the paper, and it separates out the compounds. This is a distillation apparatus. You heat up a liquid, and then you condense the vapor, and this lets you separate out mixtures as well.